Hello everyone, let's go through some problems. In this problem we have multiple parts, and we're being asked to find the number of significant figures in each of this set of numbers. Now remember that when we have a measurement, the significant figures in that measurement are the digits that are necessary for conveying both the value of the measurement and its precision. And there are a number of different rules we can use to determine which digits are significant. Let's start with part A, where the value we're given is 214. Now this first part is fairly simple, because one of the rules for significant figures is pretty straightforward, and it's that every non-zero digit is considered significant. So we've got 214, all three of those digits are not zero. So since there are three digits in the number, there are three significant figures in part A. In part B, the number is 81.60. Okay, so this time we do have a zero. Is it significant? Well, because the number has a decimal point, we do have a special rule for figuring this out. Now, according to the typical rules for significant figures, any zero that is considered a trailing zero, meaning any zeros on the far right side of the number, at the end of the number, after the last non-zero digit, will be considered significant if the number has a decimal point. So because this number has a decimal point, then any zeros at the end of the number after this 6 would be considered significant. So the 0 is counted here. So all four of these digits are significant. For part C, our number is 7.03. This time there are no trailing zeros. There are no zeros after or to the right of the final non-zero digit, that 3. But we do have a 0 in between the 7 and the 3. Now, one rule for significant figures that is fortunately pretty straightforward is that regardless of whether or not the number has a decimal point, any zeros that are kind of sandwiched between other non-zero digits will be counted as significant. So because there's a 7 to the left of this 0 and a 3 to the right of it, we count this 0 as significant. So once again, all three digits here are significant. For part D, our number is 0.03. This time we have a number that has a decimal point, but rather than having any trailing zeros, so zeros to the right, at the end of the number on the far right side, this time we have some leading zeros. So these are zeros that are on the far left side of the number, leading up to the first non-zero digit being that 3. Once again, the rule here is fairly straightforward. Regardless of whether or not the number has a decimal point, leading zeros are never considered significant. The only time a 0 might possibly be significant is if it's after the first non-zero digit. So the only significant digit here is the 3. So there's only one significant digit. Part E is more or less the same type of number as part D. We got a bunch of leading zeros and then two non-zero digits at the end. The same exact logic applies. We have two digits that are not 0, the 8 and the 6, but all the other digits are leading zeros, so we don't count them. So the only significant digits are the 8 and the 6, meaning those are the only two significant digits. Part F is fairly simple because the number we're given is, again, a similar case as part A, 3236. All of those are non-zeros, so all of them would be considered significant. So there are four significant digits there. Part G, our number is 8,700, and this is where I need to give a little bit of a warning that this is where things might get a little bit confusing for some people. And it might be worth noting that this even is a case where I've even heard different teachers have different opinions on this. But most teachers and most professors would explain this part of the problem this way. If you look at the number, you'll notice that there is no decimal point, but we do have a couple of trailing zeros. I mentioned earlier that trailing zeros are considered significant as long as they come in a number that has a decimal point. But we don't have a decimal point here, so it's a little more ambiguous. The usual rule and the usual assumption is that trailing zeros are not considered significant when there's no decimal point. And that is the rule that is usually given. So taking that into account and applying that to this 8700 number, the only significant digits would be the 8 and the 7, which is only 2 digits. The reason why I mentioned that the last part is a little bit ambiguous is because I have met some professors who would argue that in a case like 8700, you can't know for sure without a decimal point being present. Because the argument being that if you were to come across that measurement, then you wouldn't know for sure whether the tools used to make the measurement were precise to the tens place or the ones place. There may be cases where someone writes a number like this, and because of the way they measured the value, they really do intend for one or both of the zeros to be significant. But if that were the case, then it's very rare you'd see the number written that way, because if the author of the measurement was trying to communicate that significance, they'd most likely represent the number differently, using either scientific notation or something like an overline over the final significant digit. So, for the most part, it's fairly safe to assume that the number given to us in part G has only 2 significant figures. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as it'll help me out in making more videos like this. And if you have a request or a question, leave a comment down below. I hope you all had a lovely day, and a lovely life on top of that. Bye-bye.